It has wings but cannot fly. It has a mouth but cannot eat. The moment it emerges from its cocoon, it enters a countdown to the end of its life. It is one of the very few insects on Earth completely domesticated by humans, unable to survive or reproduce on its own without human care. The domesticated silk moth has a wild ancestor called the wild mulberry silk moth, which still lives in the forests of China, the Korean peninsula, and Japan today. The wild silk moth can fly and flies quite well. Its body is dark grayish-brown, blending into bark and dead leaves, almost invisible. More than 5,000 years ago, ancient people living in the Yellow River Basin of China first discovered that the threads spun by this insect could be woven into cloth. They began to catch rays and selectively breed them, following simple rules. Individuals that spun more silk were kept, those that spun less were eliminated. Larger individuals were kept, smaller ones were eliminated. White cocoons were kept, dark ones were rejected because white cocoons were easier to dye. After 10,000 generations of selection, over 5,000 years, its wings remained, but its body grew increasingly heavy. Even flapping hard, it could only flutter from a table to the ground. Its body color changed from deep protective coloring to pure white, making it extremely easy to spot in nature. Yet this is not the most helpless part of its life. Most silkworms selectively bred for silk never get the chance to fully emerge from their cocoons. When a silk moth breaks out of its cocoon, it secretes liquid to soften the shell and bites an opening. Once the silk is broken, a long continuous thread cannot be drawn. So in silk production, after silkworms form cocoons, the cocoons are treated with hot water or steam to extract the complete silk thread. Every year, the world produces about 700,000 tons of raw silk. Each cocoon yields only a small amount of silk, meaning a huge number of silkworms go through their life cycles to support production. After emerging, female moths release pheromones. Male moths pick up the signal and move toward the source of the scent. After mating, the female lays hundreds of eggs. Within a few days, both male and female moths pass away one after another. They do not eat, drink, or fly, emerging, mating, laying eggs, and then departing. The pheromone released by female moths is called bombicol. It was isolated by German chemists in 1959, the first insect pheromone whose chemical structure was fully understood by humans. The antennae of male moths are covered with tens of thousands of olfactory receptors, extremely sensitive, able to detect tiny amounts of pheromone molecules in the air and lock onto the direction with precision. Why was this ability preserved above all others? Because humans did not need it to fly, but they did need it to mate and lay eggs successfully. Without eggs, there would be no next generation of silkworms, and silk production could not continue. So functions related to reproduction were precisely preserved. What would happen if the silkworm house was opened and all domesticated silk moths were returned to nature? They cannot fly far, their movement is weak. Their white bodies offer no camouflage in nature, and they cannot adapt to the wild on their own. Two types of moths evolved from the same ancestor. The wild silk moth lives freely, while the domesticated silk moth struggles to survive. Humans have domesticated many animals. Even if released into the wild, most can barely survive. Stray dogs can find food, stray cats can hunt, wild horses can still live on grasslands. Only the domesticated silk moth has lost nearly all ability to survive independently. Researchers compared it with the genome of the wild silk moth and found that many genes related to immunity, stress response, and activity were significantly weakened in domesticated silk moths. No ancient silkworm farmer deliberately set out to change the moth's ability to survive. They simply chose individuals that spun more silk and were easier to raise as breeding stock each generation. The better adapted it was to human production, the more fragile it became in nature. Today, the total length of silk produced worldwide every year, if connected end to end, can circle the earth thousands of times. 5,000 years ago, someone found a wild silkworm on a tree and took a fancy to the soft silk it spun. The fate of this entire species was changed forever.